Hello, this is going to be Chapter 0 Basic Skills. Now you might be wondering why it's labeled Chapter 0. The textbook does not cover some of the issues that you need to understand before actually delving into history. Map reading skills, place in the solar system, impacts on climate. I know it sounds overwhelming at first, but trust me, it's going to be very simple by the time we get done with this. We're going to begin with Section 1, the world. A brief look at the world you live in. Okay, let's establish where we're headed with this to begin with. By the end of this section, you should be able to explain how the tilt of the Earth on its axis affects seasonal change, be able to label the 7 continents on a blank map, given a set of coordinates, be able to locate a place on a map, and be able to correctly create and use maps. Vocabulary you should be looking for in this section will usually be highlighted in an alternating color, most commonly red. You will be looking for the words axis, orbit, solstice, equinox, Pangea, latitude, longitude, prime meridian, equator, hemisphere, absolute location, coordinates, relative location, legend, scale, and compass rose. Let's start our look at the Earth with where it's located. The Sun, as we're used to calling it, is a star that's actually named Sol, S-O-L, hence the term solar system, solar power. We are the 3rd planet from that star, which means scientifically the name of the Earth should be Sol 3, but we just call it Earth, which means basically dirt. The next closest to the Sun is Venus. It has a surface temperature of approximately 400 degrees, and the next furthest out is Mars, which has a surface temperature of approximately negative 67 degrees on average. So we happen to be located at the ideal place for where we've developed. Okay, let's zoom our focus in a little closer to home. We're going to look at the Earth. If you were to draw a line through the Earth from South Pole to North Pole, right through the center, you would have what's called the axis. The Earth spins on this axis similar to the way that a tire spins around the axle of a car. It's the center point that the rest of the Earth is pivoting around. The axis line is tilted 23 degrees compared to the Sun, approximately. This means that when the north side, the side that we live in Arizona here, is tilted towards the Sun, we have longer days and it's summer. When we are tilted away from the Sun, we have shorter days, and it's winter. In addition to this, the Earth orbits the Sun. So while it's spinning on its axis, it makes a circle around the Sun as part of the solar system, which is referred to as the orbiting aspect. In addition, the tilt affects sunlight. As we are tilted towards the Sun in the summer, we get more hours of sunlight during the day, and the days are longer. When we are tilted away, we are cast in the shadow of the Earth from the Sun more often, and we end up with longer nights. The longest day and the longest night of each year are known as the solstices, the winter solstice and summer solstice respectively. At the point when they cross and you have an equal length day and night at the same time, you end up with an equinox. These happen in the spring and fall or autumn. One easy way to keep these straight is to think of the solstice, sol, is when the night or day is so long, and the equinox is when the day and night are equal. Equinox, equal. Sol, so long. A theory has been put forward by geologists that all of the continents were originally linked together as one supercontinent, sort of like the pieces of a jigsaw puzzle having been fit together at one point and having broken apart since then. This is called the whole Earth or Pangea theory, with Pangea being the name of the supercontinent that is thought to have existed. It's based on the idea of how the continents fit together, the rock formations at the areas where the continents would be linked if they were a whole continent as predicted. It also relies on the concept that the upper layer of the Earth is resting on a magma layer, or lava, that's kind of a jello-like consistency. This allows the continents to drift slowly over spaces. I believe the last I've heard it was about a 1/4 inch per year or so of continental drift. If you would like to see animations of how this takes place, Go to the YouTube bar above and in the search type in Pangea Animations and you will find some excellent examples of the continents splitting apart in various videos. At this time there are considered to be 7 continents: North America, South America, Africa, Australia, Antarctica, Asia, and Europe. These are labeled on the map that you see now, and you will have to know how to label them appropriately when it comes time for the chapter test. Note that recently there has been a movement to include Europe and Asia as one continent since they are connected with no water separating them. This would be known as Eurasia. If you hear that term, just know that it means Europe and Asia combined. However, for this class purposes, you must be able to name all 7. To assist people in finding locations on a map, lines have been added. These work in a similar manner to graphing lines that you would use in a math class, for example, with a 0, 0 at the center, positive numbers going up or right depending on how you're trying to find it, and an XY axis, just as the math classes have been teaching you guys for a while, hopefully. The lines that run up and down on the map, north to south, are known as the lines of longitude. They run the long way around the Earth from one pole to the other. So therefore they are the lines of longitude. The 0 line of longitude, the center line from which you would begin all of your measurements to find a location, is known as the prime meridian. Meanwhile, running east to west, or horizontally, or left to right, however you would like to phrase it, you would find the lines of latitude. The 0 line of latitude is the equator, and distances would be measured from this point up or down, north or south. Using lines of longitude and latitude in a similar manner to a grid or graph in a math class, a person should be able to take a set of coordinates and find a given location. The difference between this and a math class is that you are going to be using north, south, east, and west instead of y or x as the axis. The coordinates are just the place where the two numbers cross. For example, given the coordinates 33 degrees north, 112 degrees west, you would be able to trace the lines on the above map and find the location of Phoenix, Arizona. This is an example of absolute location. An absolute location tells you exactly where something is. Coordinates, street address, things of that nature. It is basically saying it is here. In contrast to an absolute location which provides an address or coordinate type of a setup, you could also use a relative location. On the map pictured here, you will see that Phoenix is northwest of Tucson. This does not tell us exactly where Phoenix is, it just gives us a general idea where to look compared to something else. Other examples could include, I live 5 blocks from the Circle K. Walmart is 4 miles from the school. Anything where one point is being compared to another instead of being given an exact location of its own would be a relative location. The last thing we'll discuss in this section is the legend, also known as the key for the map. The legend is the part that explains what the symbols on a map stand for. It will also usually include the scale, though that can sometimes be found elsewhere on the map. The scale allows you to know how far on the map equals how far in real distance. Obviously, we cannot draw the entire state of Arizona on a map life-size, but if you know that 1 inch equals 10 miles, you can measure 3 inches, multiply it, and get 30 miles. This is how the scale works. Also, you should be able to find somewhere on a map the compass rose. The compass rose will tell you which way on the map is north, south, east, and west. Some of them only label north, however, and some don't label the directions at all. It is important to know from north which way the other directions are, and that if no direction is labeled, the predominant arrow will be pointing to north by default. To remember this, some people go clockwise around it with "never eat shredded wheat," or other such terms. It is up to you what you want to use to try to remember this, as long as given a compass rose you would be able to label it, and given one that only has north indicated, you would still be able to find east, west, and south.